Okay, so in this video, we're going to talk about converting from rectangular equations to polar equations. So a rectangular equation will have x's and y's in it, just as rectangular points have x's and y's. And then our polar equation will just have r's and thetas, maybe just one or the other. So we just need some conversion factors here. X is equal to r cosine theta. Y is equal to r sine theta. These two should be pretty familiar to us. Then we have r squared is equal to x squared plus y squared. And this is a variation of r equals square root of x squared plus y squared, where you have squared both sides. The last one is that tan theta is equal to y over x. So armed with these conversion factors, we can start converting some equations. So let's start off with something basic. Let's start off with, say, x equals -6. And we're solving this for r. So we'll just convert this x. X is r cosine theta, and then this is equal to -6. So to solve this, we just divide both sides by cosine, or multiply by 1 over cosine, which is what I'm going to do. So this and this will reduce. So we're left with r is equal to -6 times 1 over cosine theta. But we know that 1 over cosine theta is just the same as secant theta. So our final form is r is equal to -6 secant theta. So the rectangular form of the equation that we started with is x equals -6. And then the final polar form solved for r is r equals -6 secant theta. All right, let's do another example. Let's start off with 2x minus 5y minus 2 equals 0. So we need to convert these x's and y's, and they're not squared up anyway, so we can't use that clever r squared term. So we'll just use the regular terms directly. So 2r cosine theta for the 2x minus 5r sine theta for the y, and then 2 here minus 2 equals 0. And we are trying to solve this equation for r. All right, so if we look, these two terms have r's, but this term doesn't, so we need to get this to the other side. So we'll add 2. So we're left with 2r cosine theta minus 5r sine theta is equal to 2. All right, now there's an r in common to both of these terms on the left-hand side, so we can factor that out, r. Then we'll have 2 cos theta minus 5 sine theta, and this is equal to 2. Finally, to solve for r, we divide by the term here. So we'll have 2 over 2 cos theta minus 5 sine theta. So our original rectangular form is this, 2x minus 5y minus 2 equals 0. And then our final form is polar, solve for r. R equals -2 divided by 2 cos theta minus 5 sine theta. Okay, so here's one that is going to use the r squared term. All right, so we're going to take this equation, x squared plus y squared plus 8y equals 0, and convert it to a polar equation solved for r. So you may be tempted to just use r cos, r sine, and then r sine here again. But when we look at this, this is actually one of the terms that we had a conversion for directly, which is just r squared. Then we just add on 8y, but y is equal to r sine. So we can factor out the r's here. So to factor out the r's, we can just factor one of them. That'll leave an r plus 8 sine theta equals 0. Now, this is just sort of like any other factored terms. Either this is 0 or this is 0 since this product is 0. So we get either r is 0 or r plus 8 sine theta is equal to 0. Now this is not good. R being 0 would mean that you're just stuck at the origin, and this is some sort of curve. We don't know what it looks like exactly, or maybe we do, but we know that it's not a single point at the origin. It has more solutions than that. So that leaves us with this guy here. So by subtracting this part over, you get r equals negative 8 sine theta, which is our answer. So the original rectangular form was x squared plus y squared plus 8y equals 0. And then when we converted it to a polar form and solve for r, we get r equals negative 8 sine theta. All right, let's do one more. Okay, so all of the ones we've done before this, we're solving for r. In this case, we're actually going to solve for theta. So it's going to be a little bit different than before. So if we look at this guy here, we could just approach it directly using our normal conversion factors. So y is r sine theta is equal to square root 3 r cosine theta. Okay, well, we don't want all these r's together. We can sort of move everything to one side like this. So we subtracted the square root 3 r cos to the left-hand side here. And then I'll factor out the r. So we have sine theta minus square root 3 cosine theta is equal to 0. So again, we could possibly have r equals 0, but that's no good. So we're just going to work with this part here. So sine theta minus square root 3 cosine theta is equal to 0. So at this point, we may seem a little bit stuck, but we're going to use a little bit of a trick here. We're going to add this back over and then do some division. So if we add that term over, we have this. Sine theta is equal to square root 3 cosine theta. And to get our thetas on one side, instead of like having them added or subtracted, I'm going to divide. So this will reduce, and then sine over cosine is tan theta. So tan theta equals square root 3. We just need to solve for theta. But we know where that is. Tan theta equals square root 3 actually has two solutions at theta is equal to pi over 3 and at 4 pi over 3. But we'll just take this pi over 3 option here. All right, so this was sort of the dive right in approach and just use these sort of algebra tricks to get through the problem. But if we were paying really close attention, there was this sort of weird conversion factor that we had that we haven't really used yet. Tan theta is equal to y over x. And if we look, we can actually introduce that at the very first step by dividing both sides by x. So y over x is equal to square root 3, which means that tan theta is square root 3. So we get the same thing we got going the other way, which is good because you want to be able to solve a problem multiple ways and come up with the same solution. But this required us to say, oh, well, we could introduce y over x, which would be really convenient in this particular case. Okay, So I think that's one of each kind of problem. If we need to do some more examples, we can do that in a later video.